Operation of galvanic cell. So we will be discussing operation of galvanic cell based on this diagram. So from the diagram we can see zinc and copper as electrode. We know that from the previous video, zinc has more negative value of XRP, so zinc is the anode. Zinc also more electropositive than copper. Therefore, zinc will undergo oxidation based on this equation. From the equation, we can see that the oxidation number of zinc increases from 0 to positive 2. Zinc electrode release electron, therefore, it is a negative terminal. Since the electrode is converted into zinc to plus, ion zinc to plus, we can observe that the electrode is dissolving. Electron will flow from anode to cathode through external circuit, which is the wire. From the explanation, we can see that zinc is the anode and zinc will undergo oxidation. So the perfect way to memorize this is by using N ox. N for anode and ox for oxidation. So next, let's take a look on what will happen at the second half cell. We know that the electrons will move through the wire to the copper electrode. Next, the copper ions in CuSO4 solution will accept the electron to form copper atom. Okay, the reaction is based on this equation. So as we can see, the oxidation number of copper decreases from positive 2 to 0. This indicates a reduction process is happening. Therefore, the copper electrode is the cathode. Okay, so what will happen? Copper electrode receives electron, thus it is the positive terminal. When copper to plus is reduced to copper, we can see that reddish brown solid will be deposited on the copper electrode. The best way to memorize this is red cat. So red is for reduction, cat is for cathode. So we know that anode we will have oxidation and cathode we will have a reduction. Other things that you need to remember is RIG, rig. So reduction is gain, meaning to say electron is gained during the reduction process. Okay, these slides will show the observation from at the anode and also at the cathode. So at the anode, a zinc electrode will loses weight and become thinner. But at the cathode, copper electrode gains weight and the size will be increased. Reddish brown solid is deposited, and we know that copper sulfate is blue in color. So when copper ion are removed, the blue color of the solution fades. Next, let us continue to discuss about salt bridge. So salt bridge is a connection containing a weak electrolyte between the oxidation and reduction half cells. So the main function of salt bridge is to help maintain the ionic balance in the cell by allowing the ions to move between the two electrolytes. Salt bridge also completes the circuit by allowing ions carrying charge to move from one half cell to another. At anode, zinc to plus ions will enter the solution, causing an overall excess positive charge. So what will happen? Cl- ions from salt bridge move into the zinc half cell. While at cathode, copper to plus ions will leave the solution. This will cause an overall excess of negative charge. Thus, the K plus ions from salt bridge move into copper half cell. So this is how the electrical neutrality of the solution is maintained by using the salt bridge. But what will happen if there is no salt bridge in galvanic cell? Okay, we know that before the wires are connected, the solution in each beaker is neutral. So they have an equal number of positive charges and also negative charges. The zinc electrode, which is the anode, will give up 2 electrons. So that electrons will flow to the copper electrode, which is the cathode, through the wire. Therefore, the solution gains a positive charge since zinc loses electron. While at copper electrode, it will take 2 electrons, causing the positive copper ion to leave the solution and accept the electrons. When this happens, an atom of copper will be deposited in the copper bath. Hence, the solution becomes negatively charged. This would halt the reaction and the generation of electricity.